Hey guys, Miss Miklos here, and today we're learning the third method of solving quadratic functions, and this is my personal favorite way, completing the square, otherwise known as CTS. And some pros about completing the square. First of all, it always works. We will find factoring and square rooting, even though I think those are the two easiest methods, do not always work. So we need to have some methods that will work every single time. Completing the square is one of those. In order to figure out how to complete the square, we need to learn how to create a perfect square trinomial, otherwise known as PST. So that's what we're going to start off with doing. So our goal is to find the constant that creates a perfect square trinomial. So our first one, x squared minus 12x, we need to figure out what would we add to create a perfect square trinomial. So I want you guys to just kind of think for a moment on what it would be before I write it down. I'm not going to reveal how I got this yet. We'll kind of figure it out. But x squared minus 12x, I would put plus 36. So you may or may not have gotten that, but let's do another one now. What should we put here? If we have x squared minus 6x, I'll give you guys a second to think about it. And I'm going to put plus 9. Let's go through one more and kind of figure out how we're getting this. If we have x squared plus 20x, what number should we put? And I'm going to put plus 100. And some of you are probably with me and some of you may be a little bit confused, but what we're actually doing is taking the middle coefficient, dividing it by 2 and squaring it. Okay, so let's look. Negative 12 divided by 2 is negative 6. When I square that, I get 36. This actually factors into x minus 6 squared. The reason being, negative 6 times negative 6 is 36. Negative 6 plus negative 6 is negative 12. Our next one, negative 6 divided by 2 is negative 3. Negative 3 squared is 9. This factors into x minus 3 squared. Our last one here, 20 divided by 2 is 10. 10 squared is 100. This one factors into x plus 10 squared. Okay, and in our lesson today, we are going to have to take a perfect square trinomial and factor them. And the thing I want us to see is that this number that we are adding to x or subtracting from x is always half of the middle coefficient every single time. So let's actually do one together here. If we had x squared minus 5x, I would take negative 5 and divide it by 2, which is negative 5 over 2, yes, a fraction. When I square that, I would get 25 fourths. So when I factor this, it would become x minus 5 halves squared. So our steps for completing the square. Step number 1, we are going to move our constant over to the other side. Step number 2, I'm going to have to divide everything by the leading coefficient. Step 3, we are going to create a perfect square trinomial like we just practiced by dividing by 2 and squaring. Then I need to add that square to both sides. Lastly, we are going to factor it and then solve using plus or minus square roots. So here we go with number 1. First thing I want to point out is, can this be factored? Are there factors of negative 1 that add up to be negative 8? And our answer is definitely no. So I'm going to have to go ahead and try and complete the square here. So I'm beginning by moving my constant over to the other side. Notice that I left a blank space here. My next step would be to divide everything by the leading coefficient. In this case, our leading coefficient is 1, so I know anything divided by 1 is itself, so I don't really need to write that out. Next thing we need to do is figure out what should I add to make this a perfect square trinomial. So I am taking our middle coefficient, which is -8. I'm going to divide it by 2 and square that. So I need to add 16 to both sides, because I know whatever I do to one side, I have to do to the other side. Now when we factor this, I know it's going to be x plus or minus something squared equals 17. Okay, and we learned our shortcut that this value is always half of the middle coefficient. So it actually becomes x minus 4 squared. The reason being, if I FOILed this out, -4 times -4 is 16. -4 plus -4 is -8. Now I need to square root both sides, and I'm going to put a plus or minus out in front. So I get x minus 4 equals plus or minus radical 17. I actually cannot simplify radical 17 at all. So I get x equals 4 plus or minus radical 17. Okay, these are real answers. If I put this in my calculator, we could simplify it into a decimal. And it makes sense we get two different answers, 4 plus radical 17 and 4 minus radical 17, because of this squared value. So let's just recap what we did. We moved our constant over to the other side. I divided everything by 1. We created a perfect square trinomial by taking my middle coefficient and dividing it by 2 and squaring it. I added that value to both sides. Then I factored it, and we had to square root both sides. From there, I simplified and isolated and got x all by itself. Okay, let's do it again. This is something that I definitely think the more we do it, the easier it gets. So I'm starting by bumping that 3 over to the other side. Once again, I have a leading coefficient of 1, so when I divide by 1, it really doesn't change anything. So I need to figure out what should I add to create a perfect square trinomial. So I'm going to take this 10, divide it by 2, and square it. So I get 25. So I know I need to add 25 to both sides. Now I'm going to factor, and this actually becomes x plus 5 squared. This plus 5 is half of that middle coefficient, equals 28. I need to square root both sides, so I have square root plus or minus, and I get x plus 5 equals plus or minus. When I look at 28, if I did a factor tree, I would get 4 times 7, or 2 times 2 times 7, and I know I can take that pair out, and I'm left with a 7 on the inside. Finally, to get x all by itself, I would subtract 5, so I get x equals -5 plus or minus 2 radical 7. Okay, I know I'm going through these steps kind of quickly. If you need to rewind it and kind of watch it again, I would encourage you to do so. Okay, repetition. Here we go again. We are starting by bumping that 5 over to the other side. This one is more difficult because all of a sudden I have something other than 1 as my leading coefficient, so I need to divide everything by 2. And I get y squared minus 3y equals -5 halves. Now, I need to figure out what to add, so I'm taking our middle coefficient, which is -3, I'm dividing it by 2 and squaring it. So I'm actually adding 9/4 to both sides. When I factor this, I would get y minus 3 halves squared. Okay, -3 halves is half of this middle term, and once again, -3 halves times -3 halves is 9/4. -3 halves plus -3 halves is actually -3. When I combine my like terms on the other side, I actually get -1/4. So I'm going to square root both sides, and I know I need plus or minus. So I get y minus 3 halves equals plus or minus, and we have two major problems here. First of all, I have a negative, which signals to me that I'm going to get an I as my answer. Secondly, I have a fraction, so I know I need to square root 1 and I need to square root 4, and I end up getting 1/2. Lastly, to get y all by itself, I'm going to add 3/2 to both sides. So I get y equals 3/2 plus or minus 1/2 I. Number 4, if we look at this, it's kind of all out of order. So I'm going to multitask here. I'm going to add 6y, and I'm going to bump that -3 over. Next thing I need to do is divide everything by our leading coefficient. So I get y squared plus 3y equals -3/2. Next, I need to figure out what should I add to create a perfect square trinomial. 3 and divide it by 2 and square it. So I get 9/4, which is what I need to add to both sides. So when I factor, I get y plus 3/2 squared equals, when I add -3 over 2 plus 9/4, I end up getting 3/4. So now I know that I need to square root both sides, and I'm going to put plus or minus square root, and I get y plus 3/2 equals plus or minus the square root of 3 over the square root of 4, but we know the square root of 4 is 2. So lastly, I need to subtract 3/2 from both sides, so I get -3/2 plus or minus radical 3 over 2. As you guys can see, this method itself is very repetitive. It is something that the more I do it, the easier it becomes. Last problem I'm going to go through, and if you need more help on this, I would go back and kind of rewatch some examples again. 8x squared plus 4x equals 3. I'm bumping that constant over. Just so you know, it doesn't get any harder than the ones we're going through. Okay? This is as tough as it gets. So the next thing I did here is I'm dividing everything by the leading coefficient. So I get x squared plus 1/2 x equals 3/8. So I'm going to take my middle coefficient and divide it by 2. I know dividing by 2 is like multiplying it by 1/2. So I get 1/4, and I need to square that, and it becomes 1/16. When I factor this, it becomes x plus 1/4 squared, because I know 1/4 is half of 1/2, equals, when I add 3/8 and 1/16 together, I get 7/16. So now I'm going to square root both sides, plus or minus square root over there. I get x plus 1/4 equals plus or minus radical 7 over radical 16, which is 4. Final thing I'm going to do is subtract 1/4. So I get x equals -1/4 plus or minus radical 7 over 4. So this method is definitely a plus if we want to just make sure we're doing the same thing all the time. Notice there isn't really memorization. I just need to know how to get it in the correct form. Regardless of what the problem looks like, we're doing the same thing every single time. As I said earlier, completing the square will always work for any type of quadratic function that we deal with.